Hi, hello everyone. So, welcome to my YouTube channel. Today I solved the problem Leetcode 2435 paths in matrix whose sum is divisible by k. This is today's Leetcode challenge. Sorry for delay. I can't record it, but now I'm going to record. So you are given a zero index m cross n integer matrix grid. ओके सो आपको क्या है, आपको एक ग्रिड दिया होगा m क्रॉस n मैट्रिक्स का. ओके एंड एन इंटीजर k. ओके एंड एक इंटीजर k आपको दिया हुआ. ओके यू आर करेंटली एट पोजीशन 0,0. ओके लेट्स सपोज यू आर हेयर 0,0. ओके and you want to reach position m-1 and n-1 moving along down or right. Means you can move only right, down or right. Means या फिर आप राइट जा सकते हैं या फिर आप डाउन जा सकते हैं. सिर्फ दो ही जगह आप मूव कर सकते हैं. एंड यू हैव टू रीच टू द लास्ट बॉटम डाउन कॉर्नर, दैट इज n-1, so m-1 or n-1, that is this last cell. You have to reach in this last cell. We have to return the number of paths where the sum of the elements of the path is divisible by k. Means the path which we have followed, the sum of all the elements which we covered in the path which must be divisible by k when we reach in the last cell. Okay, since the answer may be very large, answer may be later, return it modulo. Okay, so this will handle in the last problem. Okay, let's come on example. Okay, there is a grid. Okay, m cross n, that is 3 cross 3 grid. Okay, this is first path. We can see here we can go 5 to 2, then 2 to 4, then 4 to 5, then 5 to 2. This is last cell and this is starting cell. Okay, when we reach in the last cell, the sum of all the elements which we covered this in this path must be divisible by k, that is 3. Okay, and there is a sum of, here is the sum which covered, that is 5 plus 2 is 7, 7 plus 4 is 11, 11 plus 5 is 16, and 16 plus 2 is 18, and 18 is divisible by 3. Okay, so this is path 1, and the path 2 is 5 to 3, that is 8, 8 plus 0 is 8, 8 plus 5 is 13, and 13 plus 2 is 15. Means 15 is also divisible by 3. So this is also the path. Okay, so we got two paths, and there is no more paths available which is sum of the elements divisible by 3. So no, there is no remaining paths. Okay, so only we got only two paths. Okay, let's go on example number 2. See, the example is given of 1 cross 2 matrix. Okay, and divisible factor is 5. Okay, so we can see that we can only go right, we can't go down because कोई सेल है ही नहीं डाउन जाने के लिए. So we only go right. Okay, when we go from 0,0 cell to 0,1 cell, we only got the sum 0. Total sum is 0. From first cell to last cell, we get total sum is 0. And 0, we know that 0 is divisible by any number, any except 0. Okay, any number. So 0 is divisible by 5. So we get the one path, and there is no more path available. Okay, so we get one path. So answer is 1. Total number of paths is 1. And this is also the example which is very large, so I can't explain you this. Okay, you can go through this as well. Now we move to the approach number 1, that is recursion, simple recursion method. Okay, so as we only move to down and right, so the problem break into down or right. We write the recursion problem in which we go down and right. Let's see. I write the code already because the time is very limited, so that I don't want to consume your lot of time, so I write it already. Okay, so I going to explain this code. Okay, so first, this is right path, this is down path, and this was his right path. This is right path. Okay, means right path means we go down, we go right, and down path means we go down. Okay, so what we do, let's understand. When firstly we are on 0 comma 0. Okay, firstly we are on 0 comma 0. Let's see here, we are on 0 comma 0. Okay, 0 comma 0. So first we covered 5. Okay, so we start our our solution, our function, solve function from grid, and we pass 0 and 0 means 0 comma 0 cell number. Okay, and the sum is 0. Okay, we pass the sum is 0. Okay, in the solve function. So the base condition is what? Base condition is that when we reach in the cell of last cell, that is m minus 1 and n minus 1, then we check that the sum which we count is must be divisible by k, is must be divisible by k. If it is not divisible by k, then we add 0. If it is divisible by k, then we add 1. Okay, means we get one path. Okay, so and also we have to check that we don't go out of bound. Out of bound means if I is equals to m and z is equals to n, where m and n is the size of the grid, so we return 0. Okay, so we return 0 means we don't get any path from this path. Okay, okay, so we count so let's understand here that I don't count the sum of the sum of the elements. I add the remainder, that is I have to write remainder, not mod. Okay, remainder. Okay, remainder. Okay, why remainder? Because when we try to add sum, okay, when we try to add sum, the sum at last, when we get large test case, the sum get जो sum है आपका वो बहुत ही large जाएगा, बहुत ही बड़ा हो जाएगा, so that it goes out of bound. Okay, means it cannot lies between the 32-bit integer, so we add the remainder with the current cell. Okay, current cell element. Okay, why remainder? Why we add remainder? Let's understand it. What we do, let's sum plus grid value. Okay, grid cell value and percentage of k. Let's break it. Sum percentage by k plus grid of I j percentage by k. Okay, mod of k, sorry, percentage बोल रही मैं, mod of k, and what we write, some mod of k, what we can do, what we can write, some mod of k, क्या हम लिख सकते हैं इसको, that is remainder and plus grid of I, grid of j. Okay, grid of I, grid of j. Okay, and percentage of mod of k. Okay, so यही यहाँ पर भी लिखा गया है. Okay, understood. Okay, grid of k, and यहाँ पर ये remainder grid of j. Okay, so we can write it here. So it don't goes here as remainder plus grid ij and modulo of k. Okay, so So if the new remainder or new mod, we can write is as new remainder. Okay, so new remainder is the good variable. Okay, so if the new remainder is equals to 0, means the sum which we get till in this path is divisible by k. So that's why we get the remainder is 0. So we return 1 or we return 0 if we reach the last cell. Okay. ओके, ये मैं आपको बात समझाऊंगी. दिस इज डीपी फॉर handling large test case. Okay, so this is we got path 1 and path 2. That is, path 1 is from down and path 2 is from right. Okay, sorry, path 1, okay, so good. Path 1 is from down and path 2 is from right. Okay, and we add because we want the number of paths. Okay, so we add path 1 and path 2 with the modulus of m, where m is the modulus which is given in the problem. Okay, so we actually we I take the long for 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 comes in a 32-bit integer, so I take long and then convert it into int. Okay, for return path. Okay, so when I run this code, so so this is accepted. But if I don't is use dp, without without memoization. Okay, without memoization. Okay, without memoization, when I run this code or submit this code, so it gave TLE. Okay, I will show you. Okay, I will show you. First I remove this TP. Okay, ये run देते हैं. Okay, so I run it. Let's see how much test. Okay, wait, I have to make it new remainder. Okay, not new mod. Okay, new remainder. Okay, now run it. Okay, let's see. Okay, all test cases passed. Okay, let's submit it. It should give TLE. Okay, let's see. It give TLE because I don't it memoization. I didn't it memoization. Okay, good. 73 test cases are passed. Okay, not bad solution. Let's memoize. Okay, using DP. Actually, we take three variables. Which variables are changed? DP is of DP. We take the size of the DP on the basis of the number of variable changes. That is, I changes, j changes, and the remainder changes. So that's why I take 3 3D array. Okay, and firstly I check that if the dp of ij and remainder is not equal to -1, then we directly return because we got this path earlier. Okay, before that. Okay, and if we not get any path, and for which we have to store the new path in the dp. Okay, and we initialize here, initializing the 3D array. Okay, 3D array, and here we declare. Okay, here we declare the initialization. Okay, almost everything is good. Now run it. Okay, first same problem that I changed the variable, so I didn't change it. everywhere. Okay, new reminder. Okay, turn it. Let's check. Okay, submit. See, submit. Okay, okay, good. Okay, its time complexity is O of NQ. We can see as we take, okay, O of NQ, or we can say O of M cross N cross K. Okay, and space complexity is also the same, because we take O of M and N and K. Okay, here we can see. Okay, now let's move to the next approach, that is bottom up approach. Okay, for this I comment it. Okay, now coming up to the bottom up approach. Now how will convert this bottom up approach into an into sorry this memo recursion approach into an bottom up approach. Okay, firstly we take the 3D array which of same size that we take in the recursion approach. Okay, and first we fill it the base case. What is base case? Base case is that when we reach the last cell, so we have to save the remainder of grid of m minus 1 and n minus 2. If the percentage, if the modulo of k with modulo of k equal to 0, then we add 1 or we add 0. Okay, and as the as there is three variables, so the for loop comes run with 3 times. Okay, so that is I equals to m minus 1 and I is greater than equal to 0 with I minus 1. Why I take why I run the I from the m minus 1, why not from I equals to 0? Because we look here, we take t of I plus 1. We don't know the I plus 1 if we move from I equals to 0, because how we recognize future variable value? No, we can't do it. Okay, so we go from from last side of I. Okay, so we got I plus 1. Here we fill it already. That is base case. And same thing we do it if I equals to m minus 1 and j minus 1, j equals to n minus 1. Then we continue because we fill it already. Okay, and the second loop is for j equals to n minus 1. Okay, and the third loop is for remainder. We know that if the divisor is k, then remainder is from what? Remainder is from 0 to k minus 1. Remainder is from 0 to k minus 1, we can see. Okay, so I take from 0 to remain less than k. Okay, or we can say remainder is less than or equal to k minus 1. Okay, and we find the new remainder, that is remain plus grid of ij modulo of k. Okay, and we take the count value, or we can say path value, count or path, or we can say total path, anything. Okay, so same thing. In the recursion we write it here. What? Solve grid comma I plus 1 comma j comma remainder. Okay, but here what we write? Here we write in the form of t, in the form of array. Okay, in the form of array. Here we write from right, that is solve grid comma j I comma j plus 1 comma remainder. Okay, and store it in the t of ij and remain, and we have to convert it into int because we take long. Okay, I take long. Okay, okay, let's run it. And here we first here we I return the t of 0 comma 0 comma 0 because we move from bottom to up, from bottom to let, that is from m minus 1 to 0, from n minus 1 to 0. Okay, okay, so from here we move, and we have to take that path where the remainder is 0. Okay, remainder is 0, that's why we take this t of 0 comma 0 comma 0. Okay, let's run it. Okay, sorry, here. Oh, I hope all test cases are passed. Let's say accepted. Okay, accepted. Okay, I hope you understand this problem. I hope you enjoy this problem. Okay, thank you so much.